We'll discuss the continuity of this function, which is a rational function. So let's quickly write down the definition of continuity of a function at a given point, let's say at x equals c. If you're trying to check continuity of a function at x equals c, the first thing we need to check is, does the function exist at c? Which means if you plug in a c, is this defined? Does it exist? Is it equal to a number? Second, we need to check if the limit of the function f of x as x approaches that number c exists, which means is it equal to a number? And finally, f of c, that is the value of the function at c, is equal to the limit of the function as x approaches c. So the function must exist at x equals c, the limit of the function as x approaches c exists, and these two numbers have to be equal, finally, for the function to be continuous at x equals c. So when we look at this function, f of x equals 1 over x squared minus 1, let's just factor the denominators to see clearly where the function has discontinuities. This is a difference of squares, so that's equal to x plus 1 times x minus 1. So we factor it first. And clearly, when we look at this function, at any point other than, so as long as x is not equal to plus 1 or minus 1, we can find the limit of the function by substitution, which means the function is continuous. So when we plug in the value other than 1 or minus 1 into the function, it's equal to the limit of the function as x approaches that number c. So it's continuous everywhere except at the two numbers x equals positive 1 and negative 1. So the discontinuities are at x equals plus 1 and minus 1. Everywhere else, the function is continuous. So on the number line, there are only 2 points at which the function is discontinuous and also undefined.